विद्यार्थी मित्रांनो नमस्कार. 11वी सायन्स फिजिक्स चॅप्टर 12 मॅग्नेटिझमला आज आपण सुरुवात करतो. क्वेश्चन 1 बघा. डिफाइन मॅग्नेटिक फ्लक्स, स्टेट इट्स SI युनिट. क्वेश्चन इज फॉर 2 marks. Magnetic flux, the number of lines of force passing through a surface is called the magnetic flux, which is denoted by phi. The SI unit of magnetic flux is Weber, which is denoted by WB. Question 2 book. Why the bar magnet is called magnetic dipole? State SI unit of magnetic dipole moment. This question is also for 2 marks. The bar magnet has 2 poles at the north and south poles with pole strength plus QM and minus QM respectively, which is equal and opposite pole strength. So it is called a magnetic dipole. SI unit of magnetic dipole moment M is ampere meter square. Question 3. What is bar magnet? Explain. Question for 2 marks. A bar magnet having magnetic pole strength plus QM and minus QM at the north and south poles respectively. The magnetic poles are separated by 2L. The 2 poles are equal and opposite pole strength. The line passing through both the poles of a bar magnet is called its axis. Consider this bar magnet. These are the 2 poles, north and south, of opposite pole length plus Q and minus Q respectively. The line passing through these poles is called axis. O is center, and line perpendicular to axis and passing through O is called equator. Length of bar is geometrical length and distance between 2 poles is magnetic length, which is 2L. So a line passing through center of a magnet and perpendicular to its axis is called magnetic equator. The distance between 2 poles of magnet is called magnetic length, which is 2L. And magnetic length 2L is 5/6 times geometric length. Question 4 book. State the magnitude and SI unit of magnetic field. The magnitude of magnetic field strength B at a point in a magnetic field is given by magnetic field B is equal to magnetic flux upon area. So B is equal to what? Magnetic flux, which is denoted by phi. Area is A. Now SI unit of magnetic field B is Weber per meter square. Unit of magnetic flux is Weber. Unit of area is meter square. So unit of magnetic field B is Weber per meter square, which is also called Tesla. 1 Tesla is equal to 10⁴ Gauss. Question number 5 book. Derive an expression for magnetic field due to a bar magnet at a point along its axis and point along its equator. Also prove that magnetic field along axis is equal to 2 times magnetic field along equator. For this we have to consider 2 figures. Figure number 1, this. This is a bar magnet. These are the 2 poles, north and south. A line passing through poles is called axis and O is center. Distance between 2 poles is called magnetic length, which is denoted by 2L. So if this is center, then this distance is L, this distance is L. That means ON is equal to L and OS is equal to also L. Now consider a point P on axis. So distance of P from center is R. That means OP is equal to R. Then PN is equal to R minus L, and SP is equal to R plus L. Consider figure 2. This one. These are the two poles, north and south. Distance between them is 12. O is center, and a line passing through center and perpendicular to axis is called equator. So consider P, a point P on equator, which is at a distance R from the center. Consider a bar magnet of dipole length 2L and magnetic dipole moment M bar. Let R be the distance of point P from the center O of the magnetic dipole. So you know OS is equal to ON is equal to L. You know NP is equal to R minus L, and SP is equal to R plus L. Note that this R is very greater than 1. We know that electric field due to an electric dipole of length 2L at a distance R along the dipolar axis is given by, from figure 1, electric field along axis is given by 1 upon 4 pi epsilon 0 2p upon r cube, where r is very, very greater than 1. Using analogy of electric field and magnetic field. Analogy म्हणजे समानता. तर इलेक्ट्रिक फील्ड आणि मॅग्नेटिक फील्ड यांची समानता लक्षात घेता आपण या इक्वेशन वरूनच हे इक्वेशन असं लिहू शकतो की मॅग्नेटिक फील्ड अलॉंग ॲक्सिस इज इक्वल टू प्लस μ0 अपॉन 4 पाय इंटू 2m bar upon r cube. This is equation 1. Similarly, the electric field on equator from figure 2. Electric field along equator is equal to 1 upon 4 pi epsilon 0 p upon r cube. R is very, very greater than 1. So by using analogy of electric field and magnetic field, we get magnetic field along equator is equal to minus μ0 m bar upon 4 pi r cube. This is equation 2. This negative sign indicates that the direction of magnetic field along equator is opposite to m bar. So from 1 and 2, magnetic field along axis is equal to μ0 upon 4 pi 2m bar upon r cube. So if you take 2 here, this will become now 2 into μ0 m bar upon 4 pi r cube. And this is the magnetic field along equator. So 2 into magnetic field along equator as आपण लिहिणार, and therefore magnetic field along axis is equal to 2 times magnetic field along equator proved. Question 6. Derive expression for magnetic field due to bar magnet at an arbitrary point P. Now consider a bar magnet. This is bar magnet of magnetic moment m bar with center at O. Let P be any point in its magnetic field. Magnetic moment m bar is resolved into two components along r bar and perpendicular to r bar. Component along r bar is m cos theta and component along perpendicular to r bar is m sin theta. So consider a bar magnet of magnetic moment m bar with center at O. Let P be any point in its magnetic field. Magnetic moment M bar is resolved about its center of magnetic moment into components along R bar and perpendicular to R bar. For the component M cos theta along R bar, the point P is an axial point. The component M sin theta perpendicular to R bar, the point P is an equatorial point at the same distance R bar. Now, magnetic field along axis is equal to mu 0 upon 4 pi into 2m cos theta upon r cube. This is directed along m cos theta. Suppose this is equation 1. Now, magnetic field along equator is equal to mu 0 upon 4 pi m sin theta upon r cube. Directed opposite to m sin theta. This is equation 2nd. So, thus, magnitude of the resultant magnetic field B at a point P is given by P is equal to root of magnetic field along axis square plus magnetic field along equator square. So, you know that magnetic field along axis is mu 0 upon 4 pi 2m cos theta upon r cube, its square, plus magnetic field along equator is mu 0 upon 4 pi m sin theta upon r cube, its square. So, B is equal to magnetic field is equal to root of mu 0 upon 4 pi m r cube square taking common. So, into bracket it will remain 2 cos theta square plus sin theta square. Now, taking this out of root, it will become square root. That means 2 will get cancelled. So, mu 0 upon 4 pi m r cube under root 2 square is 4 cos theta square cos square theta plus sin square theta. Now, you know that sin square theta means 1 minus cos square theta. So, 4 cos square theta plus sin square theta means 1 minus cos square theta. So, 4 cos square theta minus cos square theta will become 3 cos square theta. This plus 1 as it is. So, magnitude of magnetic field is equal to mu 0 upon 4 pi m r cube under root 3 cos square theta plus 1. Now, if you consider this, let alpha be the angle made by the direction of B vector and R vector. Then from 1 and 2 we get tan alpha is equal to magnetic field along equator upon magnetic field along axis. So, magnetic field along equator is mu 0 upon 4 pi m sin theta upon r cube, and magnitude along axis is given by mu 0 upon 4 pi into 2m cos theta upon r cube. So, mu 0 upon 4 pi, mu 0 upon 4 pi will get cancelled, m will get cancelled, r cube will get cancelled. That means 1 upon 2 sin theta upon cos theta means tan theta. So, tan alpha is equal to 1 upon 2 tan theta proved. धन्यवाद.